This Zoom session is being brought to you by the Fractal Bullseye Bubble Fire. Now, okay, today, all right, finally, like I said, finally we're getting into trigonometry, actual triangle measuring. And today, the law of sines, a really useful one. Okay, fine. All right, we start with a triangle. Now, okay, I left out the letter C here, but for any triangle, there's generally three numbers associated with alpha, beta, and gamma, the angles, and A, B, and C, the sides. Now, we already know that A, alpha plus beta plus gamma equals 180. So given two angles, you can get the third. But usually what you need is three of those numbers to get all the other three numbers. Except if it's just three angles, that's all you know of the angles. But this will be a relation between the angles and the sides. We start with this triangle, and we drop this perpendicular, height h. And we start looking some equations. H over B is sine of alpha. H over A is sine of beta. Written here. After we transpose the B and the A, then H equals both B sine alpha and A sine beta. And then, forgetting about H, we just transpose the sine alpha and the sine beta, and we get that B over sine beta equals A over sine alpha. So a side over the sine of the opposite angle is equal for this pair and this pair, but also the third pair, C over sine gamma. If you have a true trigonometric identity, then it remains true if we swap all the labels, alpha to beta to gamma to alpha, A to B to C to A. This is simply because, you know, the triangle is a triangle, are names for the sides, just our names. So we can swap them around, and therefore, like I said, we can add to this equation a third equal term, C over sine gamma. So A over sine alpha equals B over sine beta equals C over sine gamma, and this is the law of sines. Very useful, because if you have all three angles, in practice, all you need is two of the angles, and that gives you the third. Given all three angles and one side, see, excuse me. Sorry about that. And one side, C, then we can get the other two sides, because by transposing alpha, sine alpha, you get the A equals C sine alpha over sine gamma, and transposing sine beta, you get the B equals C sine beta over sine gamma. So given three angles and a side, you can get the other two sides, and that will complete your knowledge of the triangle. All right, and of course, like I said, if you're given two angles, then the third angle will be 180 minus the other two. Gamma is 180 degrees minus alpha minus beta. Beta is 180 degrees minus gamma minus alpha, and alpha equals 180 degrees minus beta minus gamma. So given two angles, angle, angle, you derive three angles, angle, angle, angle. Therefore, given two angles and a side, you get all three angles and the other two sides, 3A, 3S. So this will be an angle, and a side like this. Here's angle, side, angle. Given an angle, the side in between, and the next angle. And again, you get all three angles and then the other two sides. So we can now solve angle, angle, side problems and angle, side, angle problems. For example, here's an angle, side, angle problem. 45 degrees here. C is 12.0. Beta is 25 degrees. So what's angle gamma, what's side A, and what's side B? Okay, first the step is to find the third angle. Gamma equals 180 minus 45 degrees minus 25 degrees, which comes up to 110 degrees for angle gamma. So, and we have gamma, we have C, and now we can find A and B. A is C sine alpha over sine gamma. You substitute 12.0 for C, 45 degrees for alpha, 110 degrees for gamma. Push a button on your calculator, making sure that the calculator is in degree mode rather than radian mode. And you get A is approximately 9.029. B is C sine beta over sine gamma, and that will be there for 12.0 sine 25 degrees over sine 110. Oh, by the way, when you're doing it on a hand calculator, at least this one, a very neat feature is that you can, is having done this first problem, A, all you really had to do is call up, use a second entry button and call back the expression you evaluated, and use edit to change the 45 degrees and then to a 25 degrees and keep the rest the same. A bit of a time saver. And push a button on the calculator and get the B equals 5.397. You have an angle side problem. 47 degrees for A, 23 degrees of alpha, 23 degrees for beta, and 51.2 for side A. Okay, as before, we first find the third angle. Gamma is 180 minus 47 degrees minus 23 degrees, which again comes out to 110. And that's all. Yeah, okay. And all right, we have A and alpha, 51.2 and 47 degrees. Now B will be A sine beta over sine alpha. Beta is 23 degrees. Push a button. B is approximately 27.354. C, well, let's see. It's A sine gamma over sine alpha. Gamma is 110 degrees. A and alpha are the same as before. Push a button. C is approximately 65.782. Now here, okay, this problem was, it's a sort of a, well, okay, in the book, it's in the form of Q is at the top of the mountain. And from here, you have what's called an angle of elevation of 25 degrees from the horizontal. From here, you back off 1,000 feet. And of course, Q looks lower on the horizon, only 15 degree angle of elevation. And here's 1,000 feet between these 2 points. What's this distance? PQ. How far up the slope of this mountain? Okay, well, first we want to, so okay, we want to find, we have this angle here. We really need to find what this angle here is. So RPQ, this angle is the supplement of 25 degrees. 180 minus 125 is 155 degrees. A 155 degree angle in here, a 15 degree angle here. This one, PQR, we have to take 180 minus 155 minus 15, comes out to 10 degrees. In practice, we could get that this is equal to 25 degrees minus 15 degrees. It's the same kind of thing. So we have 155 degrees here, RPQ, 10 degrees here, PQR. This side here, RP is 1,000. We want to know PQ. That's easy enough. PQ over sine of the opposite angle, 15 degrees, equals 1,000 feet over sine of its opposite angle, 10 degrees. PQ over sine 15 equals 1,000 feet over sine 10 degrees. So transpose PQ equals 1,000 feet times sine 15 degrees over sine 10 degrees. Push a button, out comes 1,490.5 feet. I suppose the 0.5 feet is really a little bit more accuracy than it's called for. But I'm not against having one more decimal point than is justified by the accuracy of the data. But we proceed. Here's a tricky one. This is the side-side angle problem. Given a triangle where you know a side, and an angle. What are the other two angles? And what's the remaining side? I call it sides SSA, side angle, although obviously you could call it angle side, but for obvious reasons, I don't call it that. So given alpha, B, and A, find beta, gamma, and C. All right, here we go. We start with the law of sines, although later on we will also find a solution via something called the law of cosines, but I'll let that be for now. B over sine beta, because we know B, we don't know beta, we know A, and we know alpha. So B over sine beta equals A over sine alpha. We know beta, A, and alpha. Okay, we do a bit of algebra on it, flip up both these fractions upside down, transpose the B, and get that sine of beta, which we don't know yet, equals B sine alpha over A, all three of which we do know. So here we have a kind of reverse problem. Instead of finding a psi, we have a sine of an angle. The problem is this B sine angle alpha can be bigger than 1, but sine is never bigger than 1. So if b sine alpha over a is bigger than 1, there's no solution. That would be as if this, I think of this as a pendulum at the end of a cantilever. So the angle is raised up so high that the pendulum swings back and forth and never touches the ground. So there's no triangle to discuss. So that's one problem. If b sine alpha over a equals 1, then there is exactly one solution as the pendulum just skims the ground right here and get a right angle triangle. And if b sine alpha over a is less than 1, then the pendulum touches the ground 2 places. So there are 2 solutions where beta is arc sine b sine a over alpha, this acute angle solution, or beta is 180 minus arc sine b sine alpha over a, this obtuse angle solution. So because there could be no solution, 1 solution, or 2 solutions, this triangle, side-side angle problem, is also known as the ambiguous case. I call it the pendulum because, like I say, I imagine this is a pendulum at the end of a cantilever. So you have, for this problem, you may have to make room for 2 answers, 2 columns of answers, 2 possible values for A, for B, for beta, for for gamma, and for C. So, for example, suppose B equals 5, C equals 3, and beta equals 100 degrees. What's A, what's beta, and what's gamma? All right. We know B, C, and beta. So let's do the equation involving B, C, and beta. Here, here, and here. Gamma is the unknown. A little bit of algebra gets you that sine gamma equals C sine beta over B. All right, all 3 of which are known. C is 3, beta is 100 degrees, B is 5, 3 sine 100 over 5, about 0.59088. That's less than 1, and therefore there are 2 solutions. Now, okay, let's try and find. Draw a unit circle, go up a distance 0.59. There are 2 angles that give that sign. This angle here and this angle here. This angle here is arc sine 0.59088. This obtuse angle here is 180 degrees minus arc sine 0.059088. 59088. First case, gamma is 36.22 degrees about. The second case, gamma is about 143.78 degrees. All right, so 2 solutions. So I'm going to draw a table with 2 possible sets of values. Beta is 100 degrees, B is 5, C is 3, okay. So 36.22 for gamma, this solution. 143.78 degrees for gamma, this solution. Now, we want to know A, alpha, and A. Alpha is 180 minus beta minus gamma. So 180 minus these 2 numbers is 43.78. And then from here, A is B sine alpha over sine beta. So we have 5 sine 43.78 over sine 100, which comes out to 3.513. Curious thing happens, however, with this. 180 minus 100 minus 143.78 gives you a negative number, negative 63.78. And it's not possible. The negative angles are nonsensical. What it really means is that in the pendulum at the end of a cantilever, the pendulum is longer than the cantilever. So the second solution swings over to behind the base of the cantilever. So it's not really valid. So, okay, that's another case. We have 1 possible solution. So 1 solution here. Here we have A is 2, C is 1, gamma is 100, find alpha, gamma, and beta. And B, excuse me, I'll have to change that in the canvas. This is, which page was this? Okay. I'll change that in the canvas after class. All right, so given A, C, and gamma, we need to find alpha. So C over sine gamma equals A over sine alpha. Okay, solve for sine alpha. A sine gamma over C, which is 2 sine 100 degrees over 1, which is about 1.9696, bigger than 1. So this is an impossible triangle, and there are no solutions. And that's a solution. All right, excellent. You've done what we came here to do.